All right, so welcome all to Using Supercomputers, Part 1. We're excited. This used to be part of our 2-day face-to-face session, and we've gone virtual with the current situation. So want to thank you for joining us. Before we get started, just wanted to acknowledge the traditional owners of the land that we're on. I know that we're dialing in from a number of different locations. The Whadjuk people are the traditional owners of the land from which we're broadcasting, and we'd like to pay respects to their elders, past, present, and emerging. We have for you today a busy schedule, so we will get right into it. Your lead presenter today is Alexis Espinosa, and he is a Pawsey supercomputing specialist. And joining him in the chat where you can put your questions are Basha, Christian, and Pascal. Give a wave. There we go. Perfect. So without too much further ado, yes, if you haven't done so, I'm just going to repost the Google Doc location. Please enter your name and contact details on page 2, and then select a username and password on page 3. We'll be using that later in the session. With that, if you have questions, please put them in the chat, and Basha, Christian, and Pascal will be monitoring that. We will also have slight break depending on timing to answer some questions asking them directly to Alexis. And other than that, enjoy the session, and I will hand it over to you, Alexis.
Thank you, Anne. Good morning, everyone. Let's put our hands on it. So we are going to share this presentation with you after the session, so don't worry about it. So let's start presenting. Okay. So this is the first part of 2 training sessions that really go together. So if there is any feeling of something missing, it is because part 2 is coming next week. So this is not a complete training. So just please take that into account. So this first part, we can call it a basic training, and we are going to cover. Okay. So these are the objectives really of the full course, part 1 and 2. And both parts cover pretty much all what is written there. So, but in this first one, the main points that we are covering are in dark font. So we're going to briefly describe how a supercomputer is formed. Then we are going to jump into go and connecting to the computer, explain how this supercomputer is being shared by many users at the same time. So we need to use a special technique to be able to do our work while sharing the computer with others. Then possibly the most important part in terms of everyday usage is this submission of a basic job, because you are going to be doing that all the time. So that could be like the most important, although everything is important, I can say. And well, the last point in dark is more like a whole point covering the whole session, and you will be able to understand key aspects of supercomputing. The only prerequisite at this point is knowledge of Linux, because the operating system of supercomputers is Linux. Cool. So first, an overview. So before, we're going to work with a sketch to explain the different parts. But I guess it's good to have a visual of how supercomputers look. So this is now the #1 supercomputer. Entered the list just in June. It is a big computer, very big compared to the one that used to be, I think, for more than a year, #1, which is Summit in the US. So now #1 is in Japan. And #1 is pretty much like 3 times larger than Summit, or almost 4, with 400 petaflops of capacity, of computing capacity. Summit, around 150 petaflops of computing capacity. Those are not easily available for researchers in Australia, although we know people from Australia are using them. So you can also consider our supercomputing centers in Australia as a first step to move forward to larger systems as you work together with researchers around the world. So GADI is a new computer from NCI in Canberra, and GADI is computing capacities of around 9 petaflops, and it's number 24 in the ranking. Also available to researchers all over Australia. And in Pawsey we have Magnus. Its capacity is 1 petaflop. It is now in the list of top 500, but when launched, it was number 40 in the world. Today, number 40 is around capacity of 5 petaflops, so it's 5 times behind of that place I used to have. But still, it's a very large computer and very powerful. I could say just roughly that just compared to my laptop, it is around 5,000 times more capable than my personal laptop. So it's still huge. And the good news is that we are about to get a new system that for sure is going to be high ranked again in the top 500 list. And it's coming early next year. So just check the news and think about this training as your training for using that new system that is coming early next year. Cool. So what is in those cabinets of these big computers that reside in these large white rooms with controlled temperature, etc.? So basically, if you visualize your motherboard in your personal laptop, then what you have is a series of motherboards. Basically, we call them blades. So this blade indeed has, or can be considered like 4 motherboards integrated into a single blade. All these blades are just plugged into these chassis, one after the other, with cooling systems around them to keep them alive because of the power consumption, and a lot of interconnection between them. So these chassis, again, grouped together in what they call group, and then bigger and bigger systems building up together. So, but the point is, like here in this blade, you have this, again, as I can say, at least for Magnus, these 4 computers into a single blade, or what we call nodes. And that's the basic unit of these supercomputers, the nodes. So from these visual drawings or pictures of the supercomputers, now we jump into this sketch that is representing all that huge systems that I show you. So all those cabinets are these compute nodes represented in this sketch. So the thing is that when you want to use the supercomputer, you really don't connect or jump directly to use those compute nodes. So those compute nodes are not, if I can say, immediately available to you. So what where users connect is in other nodes, or you can consider other computing units that are called the login nodes. So here is where you connect and where you start the interaction with the big system. You can consider the login nodes just as the front desk of any institution, like you start there first. There are some other entries like the data movers nodes, and those, we need those because moving of data, it can be very intensive and can interrupt other tasks. So we need special units to do that, especially if you are moving big amounts of data. Then you have your storage or disks as in any common computer, but these are available to all these subsystems of the supercomputer. And we have the scheduler, which is basically like the manager of the computer. So you interact with the scheduler. It's not really a physical unit. It's more a software that works in all these subsystems and then controls everything. So you, as a user, interact with the scheduler. So we are going to talk a little bit more about that later. At this point, I'm going to focus first on the compute nodes. So each of the nodes, you can consider them as similar to a very well-prepared workstation at your office. So powerful, but still just a single computer, that workstation in your office. So that can be a node in the supercomputer. Then the power of the supercomputer comes from, yes, the quality of the CPUs or GPUs you have in that node, but you can have that in your office. But the point is that the power comes with this using many nodes at the same time. So first you have to do that work at the same time in between nodes. Well, first you have fast communication inside the node among the components of the node, like memory communication with the CPUs and the GPUs, and among them. This needs to be a fast communication, but also a very powerful and fast communication among the nodes, because usually these calculations are performed together among many nodes working together. Okay. So this is just a picture of the amount of cables that are behind the cabinets of Magnus here at Pawsey, connecting all the blades. Well, not a single blade connecting with all other blades, but connections are one to many, so that the communication is fast between the nodes. And that's what makes these supercomputers powerful. What else? Okay, so then, as you can have all these nodes working together, you can perform very large calculations, or you can execute a calculation faster by using many nodes at the same time in parallel, or you can perform many calculations at the same time in different nodes, possibly not communicating among them, but still you can perform a lot of work if you use many of them. We will talk a little bit more about what kind of jobs are executed in the supercomputers in the following training. What else? Okay, and as in any computer, you need storage to save your information, to save your results, or to basically set up your problem. So yes, storage in supercomputers is fast in terms of accessing the data. So reading files is very fast. And the storage is large usually. But you need to consider that storage just as a temporary working area. So once you set up your problem and you get your results, there is no place there to save or store your results for a long time. So it is temporal. You need to move your information in and out all the time. That's why we are using special units as the data movers to do that. Usually in a supercomputer, all the nodes can access this global storage. And also it's now very common to have local storage in each of the nodes just to faster communication with disk and to promote faster calculations. One important thing about this storage, and indeed all the system, is that it is a shared resource. So you need to follow some guidelines to be able to use it, and also to be educated not to affect other users while you use it. Okay, so I guess there is like 2 minutes to receive some questions if there are, or we can jump directly to the login.
At this point, there are no questions. If you have questions, feel free to put them in the chat. Otherwise, we can continue on with the next session.
Okay, so I guess this is one of the moments we are all waiting for. Let's connect to the supercomputer, isn't it? So this second part is how to do that. So how to log into the supercomputer. So what this first point says here is that you connect to the supercomputer basically to submit jobs, that is to start your calculations, to set up your workflows or manage your workflows, check your results, install software. But it's funny, but the point is that the interaction with the supercomputer is not like, well, if I can say, not very interactive as you work with your problems. So it is more defining what is going to be done and submitting the jobs, and then don't interact with the process at that point. We are going to explain that a little bit more later. But anyway, my point here is that usually you are not interacting continuously with the supercomputer while the job is being performed. One important point here is that you connect really to the login nodes, as I explained a few minutes ago. And these login nodes are computing units that are being shared usually by many people at the same time. Here we have a number around 100 users are logging to the same, if I can say, to the same computer, to the same login node at the same time. So the point here is you only use the login nodes for checking these 4 points above, but you don't run programs in the login nodes. So it is a common problem. Usually we have regularly users not understanding this and thinking that when they connect to the login nodes, they are already in a compute node and trying to run programs. So just be aware, login nodes are not the big computer, so you should not try to run programs there. If you do that, then you will affect other users that are trying to use the login nodes properly. So how do we connect? Well, we need a terminal program that can run this SSH command that is part of Linux. So you need a terminal that has Linux capabilities. So for Windows users, we already told you to install the MobaXterm. So that MobaXterm program gives you a terminal with Linux capabilities. This MobaXterm is a very powerful tool for Windows. We all like it and works really, really well. So once you have this terminal, then you need to execute the SSH command to the computer you want to, or to the system you want to connect. So for Linux is already prepared with a terminal program. You don't need to install anything. And well, you already had these instructions how to do things on Windows, Linux, or Mac. Okay, so this is an example. Once you have your terminal, you just do the SSH to the computer you want to connect. So we are going to do the exercise right now. So whatever is in blue are commands that you are going to type in your terminal. So please go to your terminal, open MobaXterm, or open the terminal in Linux or Mac and type SSH COU, whatever number you have chosen from the Google Doc, at sus.pawsey.org.au. After typing that, you will be asked for your password. So the password is also in that list of the Google Doc. You need to type it carefully, and you won't see what you are typing, so just be aware of that. And also, yeah, do it carefully, because when you fail three times trying to use trying to connect to SUS or any of the Pawsey systems, we have a security policy that IP address is going to be blocked, thinking that it is possibly an attack. So your IP address is going to be blocked if you fail 3 times consecutively to trying to log in. Okay, so okay. So I'm going to try to do it myself. So this is now my terminal. I'm going to do the SSH. So SSH, I got this account, COU001.
Terminal.
Do you want me to make it larger?
Yeah. Can I see the terminal?
Sure.
I think that you're sharing just the PowerPoint window.
Oh, really?
Yeah.
Yeah, we're not seeing your terminal at this point.
So you're just sharing the application. So it's share a different one.
Okay, share desktop. Okay, so now you see it?
Yeah.
Okay. So SSH COU001 at sus.pawsey.org.au. Enter. It's going to ask for my password. Failed again. Okay. So once you log in, you receive a message. Usually in this message, well, to be honest, I haven't read it for a long time, but one of the most important things that you receive in these messages are scheduled maintenance. So it's always to check when the next maintenance is going to be. So when we are doing maintenance, you will not be able to access the computer. So it's terrible if you have plans to do intensive work on that day and the computer is not accessible. And the next day you are traveling somewhere else. So just be aware when the maintenance dates are. They are usually the first week of every month. So we already had our maintenance in July, and then we should be displaying the next maintenance very soon for August. But I can tell you that it may happen the first week of August. Okay, so let's come back to the presentation. So there are a few questions there just for you to check what are the announcements in the message. What is the default directory where you log in? So you can check that with the command pwd. So if you pwd, then you see where you are. So that you are in the home directory of your account. That is not the place where you want to put things. So we will explain more about this in the next training, in the second part. But it is very important to know that there are different places or in the storage that are accessible to you. And at home, you don't put pretty much anything. You just set up your account and customize it to your preferences. But where you install things is in another part of another file system that is called group, and where you put your setup for your calculations and your results for your calculations is in Scratch. So we are not right now in Scratch, we are at home. So let's see what we have here. So if ULS, it seems there's nothing, no files, nothing in your home directory. But if you remember your Linux command and you display ls-a, you will see that there are files there. That files that start with a dot in their name are hidden files. So they are not seen with a normal ls. So that's why you don't see anything, but those are the files that are there already. So the second part of the exercise is, let's go to the place where you really want to set up your problems, that is Scratch. So you need to cd towards your space in Scratch. So there is a variable called my_scratch that is available to you. So if you do cd $my_scratch, you will move to that file system and to your directory where you can write things on Scratch. So you can do cd my_scratch, then check that you are there, list what you have there. There will be nothing, not even hidden files. And then you can also see how my Scratch variable is defined with an echo of that variable. So let's do that. So cd $my_scratch. Well, the prompt is already prepared to display the path where you are in. So you can see that you are on Scratch, but anyway, if you don't believe the prompt, you can do the pwd to check where you are. So the present working directory is Scratch courses 001, COU 001 for me. So this means that you are in the Scratch file system. This is the place where you want to write results and setup of the problems. And if I do an ls $-a, there's nothing. Well, there is the dot and the dot dot, which are the current directory and the directory above that. Anyway, no any other files. So we want to put some things there. That's the next slide. So the next command to execute is basically download the exercises to your account. So we have put the exercises in GitHub. So you just need to clone the repository with the git command. Git clone command. I will leave that. I should share this in the chat, isn't it? I'm sorry, I'm going to try to share this in the chat. Or you can do that. Yeah, sorry for that. Then I will, yeah, I will leave it there. So you can wait for the link to appear in the chat, or you can type that. Sorry, guys. So it's git clone http github.com Pawsey introductory supercomputing. Once you clone it, you can move into the directory that is created there and see what is there. Basically, the question is, this is just a simple exercise at this point, just to move in the system. But still, our main topic of the exercise is to log in to our system. So you are still working in the login node, and from the login node, you have been able to see what is in home for your account. You have been able to cd to Scratch and create a directory there to set up your problem and interact with the file system using the login node. So is the link already in the chat? Yeah. Okay, cool. I don't know if there is. So if there are any questions, please send them to the chat. I'm going to pass a few slides and then also make a pause just to ask for questions again. So what can happen to impede you to connect to Pawsey? Some common problems are you forgot your password. So for that, we set a service that you don't need to send any like ticket request. So we have a help desk system where you can ask us questions or explain us which kind of problems you are facing while using our supercomputers. But this specific problem about I forgot my password, we sort of got rid of it. So you can solve it yourself by accessing this self-service reset of your password. So just go there if you forget your password. Then, as I told you, we also receive from time to time a ticket saying, okay, I cannot connect to the supercomputer because I don't know why. And the reason is because we are doing maintenance. That is very common, and it has happened to me even here while working at Pawsey and saying what is happening and receiving the answer that it is maintenance day. So just be aware of that. And one more annoying problem is this too many fail logins. So if you fail, again, I told you, if you fail 3 times, your IP is going to be blocked. And then even if you type the correct password, you are not going to be able to connect. So for that, you indeed need to send an email or go to the online help desk system we have and start a ticket and tell us that you are failing to log in. This, in the more recent times, this usually happen with the graphical interfaces for transferring files. So those graphical interfaces usually have this automatic re-login when something failed in the login. So if you are transferring files and something broke, then the tools try to connect again. And if the password is wrong, then they try to connect many times immediately, and then you are doomed and blocked. So be aware of that. And our recommendation is to basically unset that automatic relogin in your transferring tools if you are using one of them. Okay. More about logging into our computers. What we did was SSH the username at sus.org, sus.pawsey.org.au, and then you were asked for your password. So this is indeed not the safest way to connect to any computer. So it is safer to use what is called SSH keys, but it is a bit, I don't know, a bit lengthy to explain in this first training, but it is the explanation how to use SSH keys is well documented in our documentation and pretty much elsewhere if you ask how to use SSH keys. So we strongly recommend you to set up this kind of connection to use as SSH key. When you use an SSH key, then we are recommending it to use sort of a password for the key. So basically the key is a set of files, and what is being communicated is these files, and they are checking some encrypted information there. So you are not sending any password to the computer. You are just sending this encrypted information. And we are recommending for the usage of the keys to set up what is called a passphrase. So this passphrase for using the key is just managed locally in your computer. It's not sent to the network, so it just managed locally, and then the information is shared through these encrypted files. So that's a more secure way of doing things, connections to our systems. Please go to our documentation and set up your SSH key to connect to our systems. Do not share your account never with anyone. If there is someone that is going to work with you, just talk to the administrator or prime investigator in your project. Add this person to your project, and then he can use the computer if it is in your project. So there's no reason why to share your account, and obviously not to share it to anyone. You need to make a good, correct use of our resources, and the password, well, not share the password with anyone, not even in the help desks. You need to be careful with this information. We're not to cover this in any of the trainings 1 and 2. This is more for, I guess, visualization topics. But anyway, there is another way to connect to our computers using the visualization tools, but not for doing what we are going to explain at this point. And just to mention, there are some tools that may open this kind of menus. So for that, you need to do the X windows, allow X windows to work. And for that, you use the -X option of SSH, but it is, again, this thing is not covered, but it is in our documentation if you need it at some point. Cool, okay. So I guess because of the importance of the topic, we can receive questions if there are any.
Yes, we do have one question. The advantages of using several smaller nodes to make one group instead of using one large node. What would be the advantages?
Several
smaller, the advantages of using several smaller nodes to make one group rather than using one large node.
Okay, yeah, well, I guess you are talking about why so many nodes instead of a very big one. Well, I guess the nodes are as large as they can possibly be. I have always thought about that too. Why, for example, the memory in the supercomputer is not.
Design limitations, yeah.
Yeah, the memory in the supercomputer there is a lot of memory there, but it is distributed node by node. So yeah, ideally you want to have a single system, but basically, I guess they have tried to make the nodes as large as they can be, but that was not enough for.
Alexis, if I can.
For that, yeah, sure.
Yes. So the reason is that processors nowadays are fast as possibly they can be because there is a limit on increasing the frequency of a processor, and this is because their temperature while working would be too high for them to work properly then. So instead of having a very, very fast CPU, fastest than anything now available, that is not possible. We use many CPUs together because that's the only way we can do more work nowadays. So we have reached the limit on the velocity of the CPU in terms of gigahertz. The only thing that we can do is to use multiple CPUs together. So that's how we are going to face the issue of the so-called Moore laws that is not more valid at this point. And also having many computers working together enables parallelism. So instead of executing instructions one after the other, in many cases you can execute many instructions at the same time because they don't depend on each other. And this is the reason why supercomputers are powerful, because they enable parallelism, in which I think that you cannot do even if you had a very, very fast CPU. Instructions would be executed sequentially. So you have to wait more time.
Okay. Cool. Thanks, Christian. Yeah, I guess we should continue. Now, sharing supercomputers is the next topic. Yeah, so the first slide in this section is we need a scheduler to manage all the resources. So supercomputers are very expensive and need to be fully utilized. We need to have them running calculations all the time at full capacity. That's the ideal thing. We try to replace them in between every 3 to 5 years. And for that, we need many users working at the same time in the whole system. But many users and many projects mean many different resources needs. So that means different job sizes, different use between projects, and all these jobs and calculations need to wait to have their turn in the computer. So for that, we need something that manages all these jobs that want to run in the computer, and the manager for that is the scheduler. Yep. Okay, so a scheduler is a program, it's a software that runs everywhere in the system. There are two main schedulers in supercomputer facilities on these days. We used to have PBS, as NCI has. That's just the name of the scheduler. And a few years ago, we have PBS, but we moved into Slurm, and both of them are used in many supercomputing centers. In this training, we are going to be explaining how to use Slurm, and not really nothing about PBS, but you need to be aware that there are at least two very common options. So if you are using computers outside Pawsey, it is always a need to know how to use a different scheduler. So the user submit jobs with the information of the resources they need to the scheduler, and then the scheduler feeds those jobs into the compute nodes. The scheduler has on its hands several queues. So basically the scheduler the user decides to which queue, and the scheduler manage the queues and decide which jobs have to run next. So it's not a queue like the first one to get into the queue is the first one that is going to be executed as a normal people queue forming just to enter a place, for example. So it's not like that. So the jobs go into the queue like that, but then the scheduler decides which goes in first, just trying to optimize basically the usage in the computer, and also completing jobs, as many jobs as possible. So what I have in this sketch right now, just marked with colors, are the idea of partitions. So, so not all the nodes in a supercomputer are available at the same time. So what managers of the supercomputers do is to group different nodes for different purposes in the computer, and then call these groups of nodes partitions. So each of these partitions have a queue, and that queue is managed by the scheduler. And as you as a user basically say, these jobs, I want this job to go to this specific queue, which means I want this job to be executed in this specific group of nodes. I will tell a little bit more about the group of nodes or partitions or in our supercomputers in a few slides later. So this is just a graph about how the scheduler is trying to accommodate different jobs in a supercomputer. So in this axis, you can think that as you move downwards, you are accumulating different nodes. So let's think that all these axis covers around 19,000 nodes. So that means that, for example, I don't know, this job that has this width, maybe a few thousand nodes, utilizing a few thousand nodes at the same time. And the thinnest, obviously the thinnest jobs are using less nodes at the same time. And then what we have in this axis is time. So this is how long a job lasts. For example, this very resourceful job utilizing thousands of nodes may last a few hours using those nodes at the same time, and then the job is finished. So the scheduler sees how the resources are being asks for, and then try to accommodate this in this Tetris style, just to make all the space useful. I don't know which color here means idle. There should be a color meaning idle, possibly white, and we don't see many white spaces there. So that means the computer is being utilized pretty much fully at full capacity. So here at the bottom, I have this text. What is the lesson for the users? You need to know that the computer is not available for you just like saying, I want to run this now. That's not going to happen usually. So, so you need to schedule your job, and also you need to, if you are used to work with your calculations or to see what is happening, to interact as the calculations are running, that's not usually the way you work. So basically you don't have to wait for your job to start in your desk for your job to start or while your job is running. So basically you need to minimize the interaction with your jobs and automatize all the steps in scripts to make this more useful. And the other recommendation is, if you have a lot of things to do, just keep submitting jobs. They will go into the queue. They will not run immediately, but will wait for their time to come and then will run. So just keep your job, keep sending jobs to the queue. Some terminology about specifically of Slurm. So Slurm is our scheduler. This link is very useful. That's the source of information of the commands you will be using for interacting with the queues and the scheduler. We also have in our own documentation explanations of the Slurm commands and how to submit jobs. So just be aware of our own documentation. So there is some ambiguity about these two terms, partitions and queue. So basically partition is a group of nodes and the queue is the list that is going to manage the jobs. But sometimes in the terminology of Slurm itself, when it uses the word partition, it is referring to basically the concept of a queue. Also, when it uses the word cluster, it is referring to all the partitions that are managed by a single Slurm, what is called here, daemon. We can call it a Slurm unit. So a cluster for Slurm is not a physical cluster of computers. So it can be different from the physical, really physical hardware. Just be aware of that. But in Pawsey, basically, there is a one-to-one relationship between cluster and physical hardware. So we have several computers here, Magnus, Galaxy, and SUSE, for example. Okay, and the last point here is that even if you are working in one cluster, you can submit jobs to another cluster using the commands we are going to see. Okay. So please, so which queues are available? So you can check which queues are available in the computer you are currently connected with the Slurm command sinfo. So if you type sinfo, you will see the queues that are available in SUSE. If you want to check the queues of or partitions available in Magnus while you are connected to SUSE, you will need to use the -m option and then use the name of the cluster you want to check. And if you want to check everything, -m, capital M, and then all. So I'm going to do that here. sinfo. SUS has a long list of queues. And also the problem with sinfo is that it is not listing just a single line for each of the queues of each of the partitions, I'm sorry. It is dividing in depending on the status of the different nodes that are there. So just for simplicity right now, just check the first column and see the changes in names that are there. So you will see the work queue, the long queue, the high memory queue, the copy queue, the GPU queue, etc. A bit more explanation in the slides that are to come. So, okay, this is the example for checking what is there in Magnus. So in Magnus, we basically have just two queues. Magnus is our big system. So we have the work queue and the debug queue. And this asterisk means that this is the default queue. So if you don't indicate to Slurm where you want to run your job, it will run in the default queue, which is work queue. Another important thing in this is info command is to check if there is anything idle there where you can run your job. So I usually do the sinfo command and check for the debug queue because I use the debug queue, and this is the queue where you should send your jobs for testing, not for a production run. So if you are testing, you want to see if there is something available to test now. So in this case, there are 4 nodes available for doing some testing in the debug queue in Magnus in this example. And if you can see, the work queue only has 8 nodes idle, so that's good. The rest of them are being allocated, or that means doing calculations. There are some other informations there, but yeah, this is one of the basic things you want to check for sinfo. Again, you need to decide where to send your jobs. So for Magnus, production runs are sent to the work queue, testing and debugging to the debug queue. In SUS, here it says smaller jobs, smaller compared to the jobs in Magnus. So if your jobs are not that large to be running in Magnus, you can run them on SUS. We have a limit time of one day, 24 hours for a job. So if you need a job to be running more than 24 hours, you need to use the long queue. So this is important to mention. If that doesn't mean that you can only run simulations that last less than an hour. So your calculations need to be able to save results before this 24-hour limit and start again from there. So that's how you usually work. So you would do checkpoints and then you restart from that checkpoint as many times as you need. But if for some reason you cannot do these checkpoints, you need to go into the long queue. So just be aware that we don't have a long queue in Magnus. So you need to modify your workflow to be able to have checkpoints and restart as many times as you need. Again, if memory is not enough, we have a high memory queue in SUS, etc. Different queues. You can check our documentation for more details about that. Okay, so sinfo gives you information about the queues, but doesn't give you information about which jobs are running in the queues. So the command to check information about which jobs are running is the sq command. So you can type just sq, or you can type sq-u, your username, to check which jobs under your name are in the queues. Or you can type sq-p. P means partition. So you are going to check which jobs are running in this partition. And then you put the name of that partition that you are checking. So let's do that. Let's do sq And then there is a huge list of jobs there, or then you can check SQ dash U. I don't have jobs there, but I will check this username, MGIL. So MGIL has 2 jobs running and 1 job there waiting for something. Or we can check SQ-P, that means partition. Let's check what is happening in the debug queue. Nobody is using the debug queue at this point. So let me come back here. So this is an example of the display when you use the SQ command, just as you saw in my terminal. And the next slide explains a little bit about what is all the information that is there. So first, the first column is the job ID. So every time a job is submitted, we're going to see how to submit jobs in a few minutes. Every time a job is submitted, you get a job ID. This is very important. You need to check. You are usually using that number to do some other management of your jobs. Then who is the user, which is the account of or the project that is going to be charged by this usage. You have been given to your project a certain amount of time, units of usage. That is the project that is being accounted for that usage. Then on which partition the job is being submitted, the name of the job. This ST column is the one that is very important. R means running. PD means pending. So these 3 jobs are running, the rest are pending. The reason of why it is running, okay, it is running, there is no reason. So in the column reason is basically the reason why it is not running. So priority means that it is just waiting for the scheduler to consider this job a job that has the, I don't know, the permission to go and run. So that is measured by the priority. So this job has a low priority, so it is still waiting. Jobs with higher priority will go first. So priority increases with time. So as the job stays in the queue longer, its priority increase, and also increases with the amount of resources that have been asked. So if you are asking to use a lot of nodes, that is a more desirable job for our systems, big jobs, and then you will have a high priority. Also, if you have consumed all your time available for your project, then you will be given a low priority for your jobs. This job is not running because there is a limit of jobs that can be run at the same time in that queue. So this job already reached the maximum, or this user already reached the maximum of jobs that can be run. So unless the other job's finished, this job will not be able to run. And dependency means that this job is waiting for another job to finish. So you can set that to start a job only when the other job finishes. So this one has a dependency with other jobs and it's waiting, not running. Cool. So this is an exercise for you. Just execute the SQ command, check if you have any job. You can use the variable $user instead of your COU001. That variable has the user you are using. Check what is running in the debug queue. You can inspect the list scrolling your screen up and down to check what is the largest job running or what is the largest job in the debug queue. For that, we mean largest in terms of how many nodes are being utilized. So, for example, in this list, this job is not running, but it's asking for 4 nodes. So you can check which one is using more nodes there. I think we're not doing very well on time. We need to keep running a little bit. Let me see. Okay, submitting jobs. Okay, I will do these 2 slides very quickly. So basically, you have been given in your project an allocation, and you have certain units for you. So you need to manage that allocation carefully, because you may run out of time available or of usage, and then you will not be able to run jobs anymore. Just check how much you have available. And for that, we have written a script that is available to all users that is called Pawsey account balance. So if you execute this command, Pawsey account balance, then you will be able to check how much usage your project has and which users are using them. Right now, well, it's difficult to check that for our training accounts, but just be aware of that. And then let's go to the submitting jobs, which is a large section, and it's a very important section for us. So how to submit jobs? You need to keep using commands for of the scheduler, so Slurm commands. The main command to submit a job, or basically the only command to submit a job, is sbatch. And then the name of the file that has the instructions that of the things that needs to be executed. So basically, in a file called script, you set and write all the steps that are going to be executed. And that is the one that you send to the scheduler with the command sbatch. Then you use the sq command to check what is happening with that job. And you use the scancel command if you recognize that that job needs to be killed if it's already running, or needs to be deleted from the queues if it is pending, waiting there. You use the job ID to cancel a job. So this is just an example, sbatch, a job script, and after submitting, you will receive basically the job ID that was given by the scheduler. This is what I have explained. What is a job script? Okay, so in this job script, you write all the steps that needs to be executed, but also at the top of the script, we call it the header, you set up a list of directives or instructions for the scheduler to understand the resources that the job needs. So you check how many nodes, for example, you're going to use. You set for how long this job needs to be running. And well, the final comment here is that just be aware of the time. If you, for example, for Magnus, the time limit is 24 hours. If you set 24 hours for every job that you have, then that is not the right way of doing it, because if your job was going to take only 1 hour to run and the scheduler thinks it's going to take 24 hours, then you will be confusing the scheduler, and also basically your job will be sitting there for a longer time than needed. Also, if you set, more important, if you set less time for your job to be executed, that's more important, more dangerous, because as you reached the wall time, then that job will be killed by the scheduler. And if you if it is a surprising kill, you may not have a checkpoint and you will need to start all over again. So just check carefully how much time you need for your jobs. So this is the kind of instructions that go inside that, that script. So these are the instructions for the scheduler. We call them directives. So a directive for Slurm starts with this hash sign and then sbatch, that's the keyword, and then the different settings you have or you want to use for that job. For example, what is the name that I'm going to set for this job? What is the project that is going to be accounted for the usage? How many nodes I need? How many tasks or processes are going to be used in this in each of these nodes? More about this in the next training session. And how many cores or CPU cores are going to be used for each of these processes. Again, more about this in the next following training. The point here is that all these settings for the scheduler are written inside the script. Important how much time you are going to need for your job. So these are hours, minutes, and seconds, and also which partition you want to submit. Just let me check what is in this slide. So as I show you, all the information is given with these directives. It is important to know that all these directives can be also, or all these options can be also given in the command you type on the terminal window connected to the login node. But it's better to write them down in the script and not in the command line, because then you have a more convenient way to work and reproduce your work. Okay, so this is the example we have for today, and it is in the exercises that you already downloaded for the GitHub. So this job is named hostname. It's going to use a group of nodes. So this is not a queue. This is just a group of nodes that has been reserved for our training. So if you want to use that group of nodes that have been reserved, you need to use the reservation and the name of the reservation. And this easy job is going to use just a single node, a single task per node, and a single core per task. It will only run for 5 minutes. And we are still recommending this part. This is a bit, how to say, well, sort of not, I don't like that we need to have this, but it is part of the way we guarantee reproducibility. So this export none means that none of the environment variables that have been set before submitting the job are being exported to the job itself. So that means that your job, the job itself, is going to start clean, and the only things that are going to be set in this job are written in this script. Nothing before the submission, nothing in the command line, nothing in the environment that was used to start the job. So that is important for when something goes wrong, to check what was happening or what is happening with your, what is causing the problem. So we need to have a clean environment. Also, this first line means that you are using bash for interpreting the script, but also the -L means that you are using bash as logging into the system for the first time. Again, it is a way to keeping this script clean, and everything that is seen inside the script is what is being used to set up the environment. So after all these scheduler settings, you have your commands. So in this case, what we are doing, we are having a loop that is asking the date, is giving the message, this is the host name, is checking this host name is a command of Linux to check what is the name of the host, and then stays there for 15 seconds and do it again. So there's a comment about reservations that I'm going to skip right now. One thing that is very important, when you submit a job, the scheduler takes all the output that is sent to the standard output and all the error messages and put them together in an output file called slurm-jobid.out. And this is the place where you check what is happening with the messages that you are expecting from your commands themselves, but also any error message that the Slurm can send or the system can send will be there. So if anything fails, it's always very important to check your Slurm out file. Okay, finally, I reached this point. So we're going to do this exercise. So we already cloned the exercise repository. You need to cd into the directory named hostname, and you will see there two files. One is a file .pbs and another .slurm. So we are just going to use the .slurm file, which is has the slurm commands. And to submit to submit that script, we use the sbatch command and the script. Also here, in this slide, I'm adding this option, the option of the reservation. If you remember, that reservation is already in the script. So at this point, there's no need to write again which reservation we are going to have or we are going to use. But I just decided to leave it there just to remind you that all the settings that are inside the script, you can put them here in the command line. But also because in an exercise a few slides below, we are going to use that command line option to make things work. But anyway, you can use it. At this point, you can use it or you cannot use it. So if you submit your job and then you check what is happening with your job with the SQ. So SQU-U, your username, that COU007, for example, or you can use the variable $user to check, then you will see the status of your job. And possibly we should have done this first. You can type on your screen, see the contents of your, no, this is the output file. I'm sorry. So once your job is running, there will be an output file generated. So you can check what is happening with the output file. So all that was, in words, let's do it less. Oh, I never cloned the exercise.
In the chat.
Sorry for this, I need to clone the exercise, then cd hostname, then sbatch hostname dot slurm sq-u $user So my job is running. If I do the cat slurm, that's the output file. I see that the host name is being displayed. If I do SQ again, my job will be running there for 5 minutes. I'm sorry. Okay, so now what you can do is to check, use another command to see what is happening with the job. You can use scontrol show job and the job ID for your job. If you don't know the job ID, you can do the SQ again, or you can take it from the output file that is there. So let's do it. Scontrol show job, and let me copy paste this job ID. So with the scontrol command, you can have information about your job. And at this point, I will not tell too much about all that information. But if you check, there is the node that is being used for that job also there, how many nodes are there, etc. So this is a useful command to check information about your job besides the SQ. I'm going fast right now because time is a problem right now. So this is the exercise 2. Execute the scontrol and check if the node is there. Now if the job is still running, let's exercise the cancellation. So you can cancel your job with scancel job ID. And then you can see what kind of message is in the output file. So let's do that now. SQ, my job is still running. So if you do scancel job ID, if I do SQ again, nothing is running there because I already canceled it. And if I do cat slurm the output, you will see that because it was a loop sending messages all the time about the host name and the time of the system, but then I kill it, then you receive an error message there that something happened, and it says job was canceled at that point. So it is this output file, the place where you want to check if something went wrong. Just always check your slurm output file. There may be many different kinds of error messages there. For example, it's insufficient memory, or the requested time was not enough. Again, it's insufficient memory. So we have a few documentation articles about these common causes of error of your jobs. So please check our documentations. You have the links here about this kind of comments. And then the final exercise I wanted to ask you to do is try to submit the job not to the work queue. If you check that job was executed in the work queue because the reservation reserved some nodes from the work queue. But what if we want to run that in the debug queue? So you can type this and you will receive an error. So it's batch partition equal debug queue host name dot slurm. So the partition is not recognized. The problem is that the reservation is in the work queue, and the setup for using that reservation is inside the script. So the way to run this script in the debug queue is to remove this thing, this line from the script, or you can tell in the command line that you are going to use another reservation. In this case, no reservation. So the reservation is none. Huh. Okay, the original problem was not, that was, okay. So now I can submit this job to a no reservation in the debug queue, and the job will be running. Let's check the debug queue. Okay. So another user was able to send some stuff to the debug queue. Cool. Let's move to the presentation. So that command failed because of the reservation, and the right command to use is sbatch indicate the partition. This should be double dash. I need to correct this. No reservation and the script, and you can check what is happening there. So the final command that we need to tell you about is the sact command for accounting. So the saccounting command can check also information of the jobs that are running or have run in the system. So in this case, so it is a bit complicated command in terms of specifying the options. But for example, we have been checking the node that was used for this job to run. So if you want to use the saccount command for checking the node, you use sact and then this kind of option, format the job ID and the node list. There are some other options. You can check by job ID, you can check by username, you can check by project name. This is a more complicated option, I think, at least for myself. You need, because it displays a lot of jobs there, so you need to define what is the starting date of the jobs to check and the ending date of the jobs to check. So for example, this command said saccounting this project Pawsey 001 starting from this date, ending from this date, and the -x just diminish the amount of information that is given to you. And then you can see what happened with this job. You can basically check a lot of information about the job, which nodes, if it completed, if it failed, etc. Cool. Yes, this was the last one. We are basically on time. Just this is the last slide. You can check all this information in our documentation, explained in another way. Please go to the documentation for checking this kind of information. These are links into that or specific topics that we covered today. And also the SLORM documentation, basically how to use sbatch, how to use skew, how to use especially that last command saccounting and all the SLORM commands.
There was a question around allocations, and there was a link included in the chat for that around the various schemes that you can go and find more information on that. One other question, how long will the machines be available for access for individuals to practice the commands?
Okay, this reservation, I think, is going to be there for the rest of the day. And then we'll go out and everything will be removed, I hope. But we didn't cover how to move your information to your own computer or to your own account. But that will be covered in the next session. But today you can keep practicing the rest of the day, I think.
Okay, great. So the accounts will be available for you to practice today, so feel free to do that. Thank you for your time and attention. We will be sending out a recording as well as a link to the PowerPoint presentation. And if you can complete the survey, it'll take you only 3 minutes. We would appreciate that as feedback. Thank you, Alexis, for leading the presentation.
Thanks
and
to everyone.
Thank you, Basha, Christian, and Pascal for being busily answering questions in the chat. And reminder, we do have a part 2 to this session next Monday. So if you're interested in attending that and have not yet registered, please go out and do so.